In this video, we're going to take a look at our arithmetic and our geometric sequences. So we've already defined our sequences to just be a list of numbers. We're going to look at two specific ones, which are arithmetic and geometric, starting with the arithmetic. So the arithmetic sequences, the key thing is that each term is found by adding the same number to the previous term. So I'm going to add 3, add 3, add 3, add 3. Or I could add a -2, add a -2, add a -2. So if I'm subtracting, I just think of it as adding a negative. This means that they have a common difference, which we label as D, and these will always be linear. That's important to us because when we write our formulas, we know that our n, because that's what we're using instead of x, will be to the first degree. Now we have two rules, our explicit and our general. So go ahead and pause and write these down, and then I'll go through and explain them. Our explicit rule, f of n equals f of 1 plus n minus 1 to the d, times d, or a sub n equals a sub 1 plus n minus 1 times d. So remember, this is just our function notation. This is our subscript notation. I'm going to talk about it using this one because this is what you're going to see most of the time in your future math classes because it's a sequence. It's just our sequence notation that we typically use. So what we're doing to find our nth term, we're going to take our first term plus n minus 1 times the common difference. That's it. The n's will stay n's. The a sub 1 is going to get replaced with the first term. The d is going to get replaced with the common difference. Our recursive rule just says to find the nth term, we take the term that came before. Remember that f of n minus 1 just means the term that came before, and add our common difference. And again, using our subscript notation, nth term, the term that came before, plus our common difference. So let's look at two examples here. Starting with example 1, we're going to first determine what our first term is, and we're just going to look at it, and that's 10. I'm going to use my subscript notation just because I think it makes a little bit more sense with our sequences here. Now my common difference, I need to figure out what it is I'm adding or subtracting to get to the next term. Notice in this case my terms are getting smaller. So I am 10 to 4, I am subtracting 6. Now what I'm actually going to say is I'm adding a -6 because I always want to think about what am I adding. So to get to each term there, I am subtracting 6. I think of it as adding a -6, so my common difference is -6. I'm going to start with my recursive formula. So my a sub n, which is just going to stay a sub n, equals a sub n minus 1. That's just going to stay a sub n minus 1, plus a -6. I'm going to write -6. So the only thing I replaced on this one is my common difference. Your recursive formula doesn't use your first term, it uses the term that came before. I know that's a little confusing, but as we do more practice, I think you'll get it. Okay, my explicit formula. This time I'm going to replace the a sub 1 and replace the common difference. So a sub n, a sub 1 gets replaced with 10, plus n minus 1 times -6. And I should simplify that, so let's go ahead and do that. So I'm going to distribute my -6. I'm distributing backwards here, but that's okay. Distributive property works that way. So -6 times n is -6n. -6 times -1 is a +6. Combining my like terms, I get -6n plus 16. Now it asks for f of 42. I use that function notation. I'm going to go ahead and switch back into my subscript notation because it means the same thing. All I'm going to do is plug that 42 in here. do my arithmetic. And then do my subtraction here, which is going to give me a negative 236. Okay, we're going to do example 2 together in class just so we can work through it, but I want to go ahead and look at our geometric sequences. So our geometric sequences are going to be found by multiplying the same number to the previous term. And again, if we're dividing, we just think of it as multiplying by a fraction. They have a common ratio, which we call r. That's the thing we're multiplying by. And these will be exponential unless the r is negative. Because if the r is negative, our exponential doesn't quite work. We'll still be able to use these formulas. It's just not going to follow exactly with our exponential functions that we've talked about before. So again, we have two types of formulas, our explicit and our recursive. Go ahead and pause right here to write these down. Our explicit, using our function notation, f of n equals f of 1, that's our first term, times r, that's our common ratio, to the n minus 1. Make sure this n minus 1 is all in the exponent position. That's what makes it exponential. So a sub n equals a sub 1 times r to the n minus 1. Now our recursive, our nth term is equal to the term before times r. Remember, we're multiplying by r to get to the next term, so that's why that works that way. Using our subscript notation, a sub n equals a sub n minus 1 times r. So let's look at an example on this one. We're going to do example 1. Again, we're going to find our first term, which is easy. We just look right there. Our first term is a sub 1 is 3. And then we need to look at what we're multiplying or dividing, but if we're dividing, we say we multiply by a fraction. Here we're definitely multiplying because we're getting bigger. 3 times 5 is 15. 15 times 5 is 75. 75 times 5 is 375. So my common ratio here is 5. So starting with our recursive formula, the only thing I'm replacing in this is the r. So I'm going to go a sub n equals a sub n minus 1 times 5. That's it. Our explicit formula, we're going to replace the a sub 1 and the r. So our explicit formula, a sub n equals, a sub 1 is 3 times 5 to the n minus 1. So the n stays so that we can find the nth term. So in this case, when I ask for f of 10, again, I'm going to switch to that a sub notation. I'm going to do 3 times 5 to the 10 minus 1, which is 3 times 5 to the 9th. And I'm going to grab my calculator because I don't know that. So using my calculator, my EOC calculator, 3 times 5, and I'm going to do to the 9th. And my answer is 5859375. Let's see if I can copy and paste. Nope, apparently not. That's not the whole thing, is it? So let's go back. Five, 8, 5, 9, 3, 7, 5. So you can see that this sequence gets real big real fast. Within 10 steps, we are at 5,859,375. We're going to do example 2 together in class. So that is it for this video.